Hello everyone and welcome to Keeru's online lectures. I am Keeru and today's topic is Haloalkanes and Haloarenes part 4. In part 1 we already studied introduction, reaction in organic chemistries, nucleophilic substitution and elimination reaction. In part 2 substitution, elimination and stereochemistry we studied. In part 3 we studied preparation and reactions of alkyl halides. Now in this video we are going to study preparation and reactions of haloarenes. Starting with the preparation of haloarenes, or we can say aryl halides. So these aryl halides are basically when benzene when halogen group is attached, this is known as aryl halides. So when we have to prepare haloarenes, so the first reaction which we study, the first preparation is halogenation of arenes. Second preparation is Sandmeyer reaction. Third is diazotization. And fourth is Schimann reaction. In this Schimann reaction we can only prepare fluorobenzene. So now starting with the preparation, the first preparation is halogenation of arenes. So we have arenes. So on halogenation, that is when it reacts with Cl2 in presence of iron or FeCl3, we get chlorobenzene. So this is how haloarenes are prepared from arenes. Next is Sandmeyer reaction. So in Sandmeyer reaction we take aniline. Aniline is C6H5NH2. Aniline on reacting with NaNO2 in acidic medium, and then it reacts with copper halide. So whatever halides we are taking over here, we will get that halide. Let's suppose if I am taking CuBr, so we will get bromobenzene. If I take CuI, we will get iodobenzene. Next is diazotization. So basically like this aniline, when it reacts with NaNO2 at 0 to 5 degrees Celsius in acidic medium with HCl, we get diazo group. Therefore this is known as diazotization. We get N2Cl. On reacting with, let's suppose here I am taking CuCl, so I will get chlorobenzene. If I take CuBr, so I will get bromobenzene. So this is how haloarenes are prepared by Sandmeyer reaction and diazotization. Now Schimann reaction is, we will take aniline, the same which we studied. Now this aniline will react with NaNO2 in acidic medium. Now in second step we will react it with HbF4 and then we will heat it. So over here we will get fluorobenzene. When we are preparing fluorobenzene, this reaction is known as Schimann reaction. So this was all about the preparation of aryl halides. Now coming on to reactions of aryl halides. So these haloarenes, they basically show electrophilic, aromatic, substitution reaction. Next is formation of Aryl Grignard reagent. Third is nucleophilic, aromatic substitution, and fourth is Benzyne mechanism, in which benzene group is involved. So now starting with electrophilic aromatic substitution. So we have chlorobenzene. So as chlorine group is attached to the benzene, so this chlorine halogens are basically weakly deactivating group. So they are ortho-para directing. Let's suppose we are performing halogenation with Cl2. So in ortho and in para position, this Cl will be attached because the Cl which is attached to the benzene group is ortho and para directing. If we are performing nitration, nitration means reacting with concentrated H2SO4 and concentrated HNO3. So nitro group will be attached to ortho and para position. Next, if we are performing sulfonation, that is H2SO4. So in sulfonation, SO3H group will be attached to ortho and para position. Similarly, if we are performing Friedel-Crafts alkylation, so CH3 group will be attached again to ortho and para position. And if we are performing Friedel-Crafts acylation, so it will perform CH3COCl. So COCH3 group will be attached to ortho and para position. Next reaction is formation of Aryl Grignard reagent. So we have over here haloarene. When it reacts with magnesium with ether, we get Aryl Grignard reagent. Thus MgX is attached to the benzene ring. So the reactivity order over here will be this: aryl iodides are more reactive than aryl bromides, then aryl chlorides, and then aryl fluoride. Coming on to next, aromatic nucleophilic substitution reaction. So aromatic nucleophilic substitution reaction, basically over here we have benzene ring. In benzene ring, this is chlorobenzene. This chlorobenzene performs nucleophilic substitution reaction. So in nucleophilic substitution reaction, this group is removed and it is substituted, like we are taking over here chlorobenzene. So chlorobenzene on reacting with NaOH, like we have conditions. This is a chlorobenzene on reacting with NaOH at 623 Kelvin, 300 atm pressure in acidic medium, we will get over here phenol. So this full group is substituted from here. It is called nucleophilic substitution reaction. Now let's suppose there is a group, that is NO2 group is present over here. This NO2 group is electron withdrawing group. So electron withdrawing group, when it is present at ortho and para position, so it increases the reactivity of haloarenes. So NaOH, it will react with NaOH, but now the temperature will be less, that is 443 Kelvin. Again the same reaction will take place, only this Cl will be substituted with OH. Same if this nitro group is attached to both the positions, ortho and para, like this NO2 and NO2, ortho and para position. So when it is attached to ortho and para position, over here NaOH, 368 Kelvin temperature is again decreased. Only what happens over here, this Cl is substituted by OH and this NO2 and NO2 will remain same. Similarly, now if nitro group is attached to 3 positions, that is 2, 4 and 6th position. So in all the 3 positions when nitro group is attached, its reactivity again increases. Now there is no need of taking this. So basically now what will happen, when nitro group is attached to all 3 positions, NO2, NO2 and NO2, so only we will warm it with H2O. Thus the Cl will be substituted with OH NO2, NO2 and NO2. So this is how reaction, a nucleophilic substitution reaction takes place. Now coming on to next, that is elimination addition reaction, that is Benzyne mechanism. So basically what happens over here, strong bases like sodium, potassium and sodium potassium amide, they react readily with aryl halides. So we are taking here over here potassium amide. So this KCl will be eliminated and thus we will get over here NH2. So this is how chlorobenzene can be converted into aniline. So in today's video we studied about preparation and reactions of alkyl halides. Hope you guys are finding videos helpful. So do like, share and subscribe the channel. Thank you.